So sorry for the inconvenience for everyone. So let's move forward. So just to quickly iterate through, we were discussing about arrays versus what is a list, wherein we discussed about the points that, like if I talk about arrays are contiguous blocks of memory, they occupy, I mean, one after the other in the context there. So retrieval becomes very, very, very straightforward in the context there. However, in the context of what do you say, a list, that's not so. I mean, they can be scattered across, and also it depends on the context that. I think we understand, right, guys? Have we all heard about? I mean, I don't know. This is called as a amoeba. I mean, I'm not sure. Have you heard about amoeba? Maybe in the what do you say? In some of the bio lectures, I mean, when we were kids and stuff, we had this. Uh, uh,
Most easiest diagram to draw in biology
Yeah,
exam.
exactly, sir. Yeah. Yeah, Raja sir says yes, sir. Exactly, sir. I mean, amoeba, if I talk about, right? The famous point about amoeba is, right, you give it a shape. I mean, you give anything, it becomes that shape. So it's like water, basically a water when you make it, pour it down. Depending on the container, it becomes that size. So it says like, so I would say I can compare a list I mean, it is basically a microorganism, that's small one, if I talk about. But I mean, we generally call these things as pseudopodia, meaning pseudo legs, pseudopodia, or whatever you call it. So I mean, it just comes out from anywhere. It's like फैलता और आता है कहीं पर भी निकल आता है. That's the whole point. So if I talk about, so an amoeba is like that. So a list is actually like that if I compare to it, because once you declare a list says give me anything and everything, I'll accommodate whatever you give me. So that's the whole point. And also in the context there, if I talk about in the context of a list, right? Versus that's the whole point. If I talk about, but however, we all studied about tuples where it is very much restricted. When you try to discuss about a tuple, it's like okay, you declared it. That's it. I'm unchangeable once you do that. So that's what we also discussed about a little bit versus set versus others and stuff. If I talk about in the context, right? So I mean that's I generally compare it to this. However, on the other hand, if I talk about an array, right? Array also says that I will be able to accommodate anything, but there is a catch here. We use the word called as homogeneity, or in the context that you can what do you say, you can store similar kind of elements within an array, versus if I talk about in the context of a list, that's what that I mean makes it really powerful, because if you have similar kinds of elements, right? So the data structure itself knows that okay, I can only I mean I'm only expecting integers, so you're giving me integers, well and good, very nice. So it will be able to, what do you say, accommodate in the manner which we talk about in the context here. And that makes the entire thing well more organized compared to any other thing, right? If I talk about. Now, if I look into, there is the idea of vectorization. We just discussed about the word called vectorized. Vectorized operations are like, we'll look into that in detail a bit, wherein we'll discuss about how things actually work out, like in the context there, right? So it creates copies of itself without having to worry about in a particular axis. It tries to create a copy of itself and then does the operation. When I say, what you say, copy of itself, also many times refer to like the atomic behavior of it, right? If I talk about in the context, right, makes a copy of itself, so that in that same axis I would use the word as axis. Then we are going to look into a few of these things if I talk about, right, and get an understanding of how these operations actually work out, right? And convenience, if you talk about, you have multi-dimensional arrays, because obviously the real world is no longer like 1D, right? So in fact, the world which we live in, has 3 dimensions, but if you can have n number of dimensions depending on the context. And generally, when we refer to a dimension, we are referring to also something called as a feature. They A very common term used in the machine learning segment also can be called as a feature, right? So the idea of slicing, reshaping, and broadcasting. This is the term which I wanted to introduce to, right? So any idea, guys, what is the term broadcasting means? Anyone would like to?
Like when we want to perform some operation with the different dimensions, which are not,
Right, sir.
by rule it is not allowed, but here we are like, expanding the size
Yes,
such
sir.
that it can be possible.
Exactly. Exactly,
It's
sir.
like as a
And
padding,
perfect.
like as a padding. Like
Huh.
whenever the equivalent number of elements are not there, then
Right, sir.
by adding zeros in it, which will make it as a equal number of element between two arrays
Perfectly said, sir.
and
Perfectly said.
perform the operation.
Nicely said. Yes, sir. Exactly. Just like Raja sir and Jay also mentioned about the same. That is exactly what is the case of a broadcasting. We will see the rules of how these actually work as. So thank you so much, sir. Very nicely said. Very correctly said. So we are also going to look into what this guy actually, how this guy is able to do it, right? In the context there. And that is what makes it as a very powerful aspect behind whatever we are discussing here. So foundations of many other scientific libraries and stuff, like we talk about pandas. Pandas, I told you, right? Most of the NumPy features, like if you talk about, right? Pandas, many of its features, or if I talk about, right, comes inherently with NumPy. If I talk about, so so a very, I mean, a fundamental understanding of NumPy is a must recommendation before starting off with pandas, and generally that is the workflow which we follow as well. So SciPy or Scientific Python, Scikit-learn, you have TensorFlow. All of these are dependent on arrays because we have seen different kinds of deep learning based structures, and especially when I talk about a very classic example is maybe a image, right? So if I talk about image is basically a array of pixel values, and these pixel values may range between 0 to 255. That's the whole point of it, if I talk about, and these are individual values, right? So, and we can imagine a big image as a array, and that's why it becomes fundamentally very strong in the context there. So I hope that's particularly clear, and I think also easy with C. Fortran is another language. If I talk about, you can use buffers in order to communicate with what order do you want to go ahead and talk about, right? So all of those things, many of the linear algebra stuff, random sampling, statistical tools, X, Y, Z, a lot of different things come into play here, right? So we'll look into it a little bit in terms of more detail. So let's move forward. So obviously, since NumPy we all know is a library, just like our many other would you say thousands of libraries across, we use the same convention, pip install NumPy, to install our specific, the NumPy version. But there is a twist. I can also use pip install NumPy double equal to a version number. Suppose I want to install a specific version of NumPy. That is also possible. But what when I use pip install NumPy, it by default goes to like the source and fetches the latest version of NumPy to be installed on the computer as said. So if I talk about not just NumPy, you can install any Python package with double equal to and the version, right? So if I talk about in case you want to work with a specific version. So, I think we can also use conda install NumPy, which you have because you create a conda environment in Anaconda. So and so forth. I do not use Anaconda here in the context there. So I'm just referring to the straightforward manner which you can go ahead and talk about, right? Depending on the context or depending on the source which you are like, depending on which platform you are running, you use different codes. Then obviously you import NumPy and stuff, right? So let's quickly go ahead and start off and look into the context here, right? So as we discussed about, NumPy is an like basically, if I talk about our arrays to be specific, right? So obviously I can alias them, right, as so and so forth. Let me also use line numbers in case we get stuck and stuff. So, a very straightforward, right out of the box, if I talk about the main function within the NumPy, if I talk about, right, which helps us to create the array is np.array. Obviously, I have few of the examples right on the bit here, right? If I talk about, you have few of those, right? This is, I think everyone understands that this guy here is a one-dimensional array, right? If I talk about, right? So I think more or less we understand that the context here that and a very important point which I want to raise here is the number of brackets which you see signifies the number of what you say the dimension of the array. So very closely, if we look into, so this becomes a one-dimensional array in the context here. Also, if I talk about, you have the array here, wherein we have the I think everyone understands and appreciates the fact that this is a two-dimensional array, which can be pretty much straightforwardly created and stuff, right? And there are a few of the major functions within the NumPy. If I talk about like the zeros, if I talk about, I want to create an array of zeros, right? So you can talk about in terms of, let's say, np.zeros. And this accepts a parameter called as shape, right? So I am saying, can anybody tell me, right? How would this array look like if I am creating it? What does this shape mean? Basically, what does that talk about? What does this translate to?
3 rows and
R,
4 columns
C,
of 0.
Perfect, perfect. Exactly. So I hope everyone understands.
tuple of
Perfectly said.
tuple
Yeah.
of R, C.
Brilliantly said, sir. This guy here is the R and this guy here is the C. And just like sir said, it is a tuple of R comma C. And just like how we talk about, right? So technically, it looks something like I must have two brackets, right? And then obviously I have three rows. That means I have row one, then I have row two, and I have row three. And I hope that's particularly understandable. And there is a terminating row if I talk about. That's the whole point, right? So perfectly said. So, and obviously there should be four elements there. If I talk about, I just introduced a zero and stuff. That's it. So three rows versus four columns, if I talk about in the context. Perfectly said. So now, similarly, you have np.ones to create arrays of containing ones. And because many times, I think everyone understands and appreciates the fact, right? Like this guy here has a very what do you say? Very important significance. Well, I mean, a full array. Why am I saying that? Mostly, you might want to create an array. Like suppose you are working with a. Let me give you some simple practical scenario here, right? So suppose you are working with a what do you say image, right? So in that case, I would like to have the same size of the image if I talk about, right? And with maybe initialized with the value of 255 because I want to do some kind of operations which let's say subtracting the subpixel values and getting some xyz value, right? So that's what makes this guy much more what do you say needed in the context of the operation here, right? So I hope that's particularly understandable. And there is this range array versus linspace array. Can anybody tell me the difference between the two?
So
Between
linspace does that. We need start, stop, and there is like 0, 1 you're given. So we want
right,
numbers
sir.
between 0 and 1.
Mm-hmm.
There are 5 values which I want. So it will divide
Okay,
it by 4, like 0, 0.25, 0.5.
perfectly said.
Yeah,
Yes, sir.
that's what
Exactly.
linspace does.
Awesome, sir.
Yeah.
And
In
right, yeah,
linspace, like 0 and 1, like first two argument, it is called the interval. Like from
interval.
where to where
Exactly.
I'm going to generate the number. And
Awesomely
the
said,
third
sir.
argument, it is called the number of elements which we required.
Right, sir. Brilliantly said. And interval. I think this is not integer, interval, just like sir said. And the width, if I talk about, right, this, because I hope everyone understands that linspace translates to linear spacing. It actually
Linspace.
means, yeah, exactly. this guy simply means linear spacing. What I basically do, just like how we have all described, brilliantly said, between these two particular ends, I am dividing it linearly exactly with that particular interval. So I need 5 numbers in order to go ahead and talk about that. But on the other hand, what happens in the A range? So linear spacing that. What happens in the A range?
In
It is
arrange,
similar
what happens,
to
10 is not included. The value 10
Uh-huh.
won't be included. It will
Okay.
stop at 8.
Hey, okay. Yeah, that's perfectly correct. Yeah, sir. Raja, sir, you had something in
it is
mind to
similar
say?
to range function, but which will
Right, sir.
generate the ND array.
Right, sir. Perfect. Perfectly said. So just like Adarsh and Raja sir have mentioned, indeed, that's perfectly correct in the context here. Let me quickly, maybe I think I did not have some, what do you say, print statements. Let's say ARR1. I have this guy here. Let me put it here as ARR2. Maybe I'll have zeros. Zeros. We have ones. Like that. And print full. We have range. So for that. Print range of ARR. And let me go ahead and lastly print this as well. Print the lens space. Perfectly said by everybody. So let's rub this off for a moment. Perfect. Just like how it is described by everyone, right? So we saw that the first one was the, what do you say, one-dimensional array. You have a two-dimensional array, zeros and ones. You have 255, which is basically 2 cross 2 because we have taken the size as 2 cross 2 and the element or a fill value to be 255. I hope that's particularly clear. And just like how we have mentioned it earlier as well, right? So if I talk about the range array, gives us from the range of 0 to 10 with a step size of 2, right? So guys, just a quick interesting question. What do you think is the difference between range and a range? Perfectly said, everyone. What do we, how do they differ? Any ideas?
I think
The
major
way they
difference
return
is
the data.
the range function, which will not generate the array, like which will
Right,
not
sir.
convert into ND array.
Okay,
A range
sir.
actually, which is used in NumPy, which can create a array also, like which can generate the number within the start value, like end value, step value, and which
Right,
will
sir.
convert into array, ND array, n dimensional.
Perfectly said, sir. That is indeed one of it, definitely. So, just like how sir mentioned in the context here, maybe in the when we talk about a range, right? So you have basically right in the context here that converts it into the ND array. If I talk about this is part of the NumPy functionality, right? If I talk about, however, this does not. If I just use range of X, Y, and Z, it does not directly give me the in the form of a array or a list or whatever. I have to deliberately say what kind of data structure do I want to store the range in that I have to specify. That becomes one major point. Perfectly said, sir. And any other differences which anyone else thinks can think of? Perfectly said.
In step size, we can give step size in a
Uh-huh.
range. Step size can be given like a decimal also. Like if I want zero point
Right.
0.5, I can
Yes.
give I can give Z value as 0.5 and a range.
Exactly, sir.
But range will throw an
Brilliantly.
error.
Yes.
Mhm.
The
Step
range
size.
Yeah, I
throws
mean, range actually designed in order
in
to
a,
count the value. The
yeah,
purpose
exactly.
is different now. That's why they don't support
Yeah.
integer.
Yeah, exactly. Just like how Ankit and what do you say? I mean, others mentioned, both of them were perfectly correct. Range was not fundamentally designed to work with, what do you say, dimensional arrays and stuff. It was not fundamentally designed to do that. It was for the purpose of counting. And when we talk about counting, we generally have a integer value to it. So just to elaborate that, just like how all of us have mentioned, maybe I'll just use few more steps here. I say range of, so this is the, I'm bringing the class range. I say 0 to 10, right? And let's take a step size of 2 maybe. So the let's look into the first point, just like Raja sir mentioned. If I talk about, if I directly run this, you just see these numbers here, which says what is your starting point, what is your ending point, and what is the step size do you want. But in order to actually see how many numbers, like what kind of stuff you get, you have to store this, or you have to basically store it in some kind of a structure. Let's say I store it in the form of a set, or maybe I say I'm just using set here. I can also use list here, right? So if I talk about, I can store it in any data structure which I like. So generally in the context there. So unless I don't do that, I get, what do you say, just what is the range I have provided, and based on that, you get the output in the context there. And but on the other hand, if I talk about a range, you directly get the value. So if I say 10 and 2, you get an array size directly, because you are actually speaking about arrays, if I talk about, right? So this becomes the first point which we were discussing, just like how everyone, with the assistance of everyone, we have. Now, coming to the second point, just like Aditya and also Ankit had mentioned earlier, right? If I talk about, right, range, if I talk about, if I just put, let's say 2.5 here, and if I run it, you wind up getting float object cannot be interpreted as an integer. I think everyone understands this particular, the reason why you are getting this particular error is fundamentally this guy has been set to being to accept integers and not float values, if I talk about, right? And that's what keeps this apart, right? But however, if I do the same here, I get, just like how we have discussed here. It does, just like Aditya mentioned, we have decimal points which can be, because NumPy are arrays, and specifically NumPy was not designed for just for counting. You can use, the plus point is you can use it for counting, but it was introduced for the whole idea of working with huge mathematical operations or specific matrices, n-dimensional, what do you say, arrays and stuff. So if I talk about, so that's the whole point behind using the context here. Perfectly said. So that's what one thing which I wanted to focus on, if I talk about. And overall, if I talk about in the context, you have the lens space and stuff. Let's move forward and discuss about few more things, right? So yeah, before I go into a little more detail, there is one more thing which I wanted to share with you. So there is, have you heard about this np.I, right?
Identical
Yes,
matrix.
identity.
Okay. Yeah, exactly, sir. It does create, if you look into the documentation, you have shift tab. If you do the shift tab, you have it creates an identity matrix, right? If I talk about, like, for example, I say 4, right? It creates a identity matrix, just like how we have discussed so far, right? And obviously, I can also say D type. I can set the D type as, let's say, maybe np dot int, or maybe I'll say int64, whatever, right? So I want it as in the form of a integer. I can set it up. But the whole idea behind why I'm discussing about it, it creates indeed a, what do you say, identity matrix, right? But the power of the I matrix is you can optionally add M here. Like, for example, let me show you what I mean by here. If I add one more parameter here, let's say 4 comma 3, right? And I run it. Can you see what happened here? So initially, if you talk about, if you don't provide it, right? By default, it takes 4 comma 4. meaning m, whatever the value of m becomes, if you don't provide the second argument, it takes it as the same. So if I talk about, that's why it gives us the identity matrix. But however, if I talk about, if I wanted like 4 rows and 3 columns, I can set it in that manner as well. But did you observe one thing, that it shows me here that last one is deprecated? It basically creates a identity matrix, but you can, if you want, you can reduce the number of what do you say, I mean, columns and rows in the context there. I hope it's particularly understandable by everyone. So that becomes an additional motivation here, right? But however, if I talk about in the context, there is a parameter called k. Let me introduce it. Let's say I set k to -1. Look at the particular output. Did you observe something different? Let me elongate this a bit. Let me make it 4 cross 4 to be easy enough. I
Yeah, yeah.
currently key value, yeah,
We can see
currently,
now the first one is ignoring it,
right.
only putting
Ex
0, 0.
exactly. Sir, the reason why this is actually called as an eye, because it actually looks like an eye if I talk about in the context. So this is the, what do you say, if I talk about, you can see like it shapes like an eye if I talk about. But just like how you can move your eye below or upwards or whatever in the context, you can use or manipulate that using the k value here. So you can create additional parameters in order to work around with the context here. So if I say, let's say k equals to 1, you will see that it is shifted towards the right on top, right? So the diagonal elements 1 are shifted to the top, right? So similarly, you can add 2 or maybe -2, whatever, right, in the context there, in the context, obviously. But I hope everyone understands that if I set the k value as 3, obviously the entire thing, you can see that it is just having one particular, like one on the one side of the matrix if I talk about, right? So obviously if I set k value to 4, it becomes completely a zero matrix, right? So this is one additional benefit of the I matrix, which one can what do you say, manipulate. But there is one more what do you say, where if you really would like to create an identity matrix, I can set it to np.identity. I can create a, there is, what do you say? There is a function, or if I talk about, right, which can create an identity matrix by using np.identity, and I set the value, it becomes a square matrix, and it gives me in the form of this. So basically, the power of identity is retained in I. Along with that, it has some additional powers. That's the whole point, right? If I talk about. So this is what I wanted to little bit shed light on. If I talk about now, moving forward, there are a few of the attributes, different kind. Every array has its own attributes. If I talk about, right, you can manipulate the shape, the number of dimensions, size, and the d type. If I talk about in the context there, right? So and you can see the context here, right? So we had that array 2, right? You saw that the shape of the array was, it was a two-dimensional array. I hope everyone recalls. So 1, 2, 3, and 4. If I talk about, right, two-dimensional array, and a number of dimensions, obviously it is 2. You have size is 4. Size is basically the complete structure. If I talk about, that is nothing but, what do you say, x into y, which gives you the size, right? If I talk about, and d type is, you can see, defined in integer 32. If I talk about, right, obviously I can change, just like how I told you that you can use a comma and put the parameter called as d type and initialize it based on the context there, right? So if I talk about in the aspect, so I think that's one thing which I wanted to discuss about, right? So okay, so would you maybe I'll go ahead and do this quickly for, maybe I'll take this. So I hope everyone understood the concept behind here, right? So let me do this little bit. I think it's well, some random stuff. Okay, I think this should be it. Yeah. So I created this array, right? Now I would like all of us to help me out. What is the maybe I'll probably ask the question as what is the first question maybe what is the shape of the array? Just randomly created an array here that I could think of maybe.
It's a 4 dimension, but each dimensions it's a 4 dimension first of all.
Perfectly, sir. Perfectly right. Awesomely said. It is a 4D array. Perfect. And I think just like you guessed the number of brackets to say which dimension it belongs to, right? Perfectly said, sir. Now, my next question would be like, what is the shape of the array, sir? So, can we also say that since it is a 4D array, the shape should be like this, right? Everyone agrees? All of us agree with this? Perfect, sir. Perfect. Awesome. So, yeah. So now all we need to do, I will start off by options. So what all things can be filled on those blanks, sir? Anyone? I deliberately gave a little bit of a complex array, just to have a basic understanding. Yeah, Raja sir, you want to say something?
I think first argument 4. I
Okay,
don't know
sir. Let
I'm
me
right
put
or
that.
wrong.
No, sir.
Let me try.
Let's see. Yeah, yeah, yes, yes, sir.
Let's
Perfect,
try.
perfect, sir. 4. Awesome, sir.
The last two, 2, 3.
Okay, sir. Okay, so there is something like this, and there is one more,
2,
right, sir?
3.
Sir.
And this 2, sir. Is it 2 or 1?
Okay,
Something
sir.
like that.
You want to say
Maybe
1, sir? 1 or 2?
1, right? 1.
Okay,
I'm trying.
I'll
I'm
put
not sure
one.
about that.
I'll put both options, right, sir?
Yeah.
Okay, sir. No worries, sir. But I'm
Let's
happy, sir,
see.
you tried. Yeah.
Yeah.
Perfect, perfect, sir. Anyone else would like to try? Thank you so much, sir. Anyone else? Yeah, Jay.
2 by 2
And yeah,
by
Ankit.
1 by 3.
Sorry, sir. 2?
2 by 2,
Uh-huh. Mm-hmm.
comma 1 by 3.
1. Okay, sir.
3.
Perfect. Okay. Any other? Yeah, Ankit Paji, you have unmuted. Please, sir. Go
Now,
ahead.
my question is,
Yes, sir.
what if I also like gave you some sort of option? Then
Yeah, sir. Yeah, definitely, sir.
will you add E option also?
Yeah, definitely, sir. Yeah.
I
Yes, sir.
just missed the
Anyway,
question. Can you tell the
Uh-huh.
question was?
Okay, sir. Ankit Paji, just give me one second. I'll just repeat the question. So, sir, on the screen, you see that I've created an array. I just randomly created this big array. You can see the print statement, right? I asked the question first initially, what is the um, shape of the array, right? And if I mean, what dimensional array is it? So everyone unanimously said it is a 4D array, which is indeed correct. There are 4 brackets, hence becomes 4-dimensional array. Perfect. Now my question was, what is the shape of the array? And obviously, since it is a 4-dimensional array, there has to be 4 boxes, right, which needs to be filled. So Raja sir gave 2 options here, A, B, and Jay sir, he has given C option, and I'm waiting for more options here. So Ankit Paji was trying to say the option. Over to you, Ankit Paji. Then others, I think you got the question, right?
Yes.
Perfect. So Ankit Paji, what do you have? After that, we can have yourself. Yes.
okay. So let's take okay, I will took these numbers from each and every
Right, sir.
option so that I
Huh,
can
huh.
get this,
Yeah,
right?
definitely, sir. No worries, no worries, sir. Go ahead.
Okay, fine. So I think from C, one I
Mhm.
would like to take, and from B also one I would like to take, and from
So,
A I would like to take two, three.
but sir, what are the numbers you want to put? How, in which order, sir?
Oh, it's one, one, two, three, nine.
Okay, 1, 1, 2, 3, right, sir?
Mm.
Is this the one you're saying? Correct, sir? Okay, perfect, sir. You had E option as well in mind. What do you think, sir? Any
No,
other
no, no,
option?
no, no, no.
Okay, this one. Okay, sir. Right,
That's
sir.
fine.
Anyone? Yeah. Perfect. Thanks, Ankit, sir. Yeah. Anyone else? Anyone else would like to say? Hmm. I think there are messages. I'm not sure whether all of a sudden my eyes went that
Yeah,
side.
yeah, 2213.
Okay, 2213. Okay, yeah. Jay says
It's already
2213.
done.
Yeah, Jay has written
Okay.
2213 already, and I have put in there. Perfect. Yeah. Anyone else? All good? Okay. Last final call. Anyone else would like to give their thoughts for numbers for 40 array? Okay, let's see how it is basically done. And let's first understand the concept, right? I hope everyone remembers one particular thing, right? You remember that I'm just going to recall one thing. It says array 2 dot size, right? The size of the array is 4. Why did it come as 4? Because we are saying this multiplied by this should be equal, right? The number of elements in the array should be equal to 4, right? It should be A multiplied by B, that should be 4, right? And that's why the total number of elements in this array 1, 2, 3, 4 becomes that, right? Similarly, if I take a bigger one, let's say I have taken this, right? NP dot ones, right? Or NP dot zeros, right? I've taken the shape as 3, comma 4. That means the total number of zeros in the array should be 3 into 4, that is 12. And let's have a look at it. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think that aspect is established by everyone, right? Is it clear for everyone? Is that concept clear to everyone? Yes. So the total number of elements, right? Technically, whatever four numbers you have given should multiply it to, let's see, the number of total numbers I've written here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of numbers which I have written here is equal to 12, right? Everyone agrees? All of us?
Yes, yes,
Perfect.
yes.
Perfectly said.
My
Perfectly said.
answer is wrong.
Yeah, sir. I
I
just
think
want to clarify.
Jay's
Yeah.
answer is right. I think.
Let's see, sir. Yeah, we'll we'll we'll
Yeah,
we'll,
yeah.
we'll go one by one. Perfect. So and then we'll decide on that. So let's go to option number A. It says 4, 2, 2, 3. That means 4 into 2 into 2 into 3, which technically is 4, 8, 8, 2, 16. Guys, maths is weak. 16 into 3 is, I think, 6,
48.
3,
48.
48. Thank you,
48.
sir. Yeah. So obviously, this cannot be the correct option. So many a times you might have seen, right? I attempt multiple choice questions in this manner, and that's why even if sometimes you don't know the answer, you still find out the answer because many times elimination helps. But we'll talk about the concept as well. Okay. So as of now, you can see and understand that option A is incorrect because there are no 48 elements in this, right? Now, coming to option number B, right? If I talk about, I have 1 here. So I just divide it by 2, right? I don't need 2 here. Let me divide it by 2. That means 24. Are there 24 elements? No. So that in that case, option B also becomes incorrect. Everyone agrees? Got it? Yes? Perfect. Perfect. Now, option, yeah. Yes, sir. Raja, sir, you have unmuted.
No, no. I already told no, my answer is wrong. That's
Haha,
what I'm
I mean,
agree on that.
sir, yeah. No, sir, that's fine, sir. We are just
Okay.
learning the concept here, sir. Many times, sir, this
Yeah.
actually it's a big confusion. Many times it happens, sir. And the more the number of elements it becomes, it is very difficult to visualize but it will be very easy post this, sir. I'm damn sure about it. It will be easy for
Sure.
in understanding the context. Thank you, sir. So yeah, now let's go to option number C, told by Jay, I think. So it says 2 into 2 into 1 into 3. That is 2 to 3 to 6 into 2. That is 12. So this could be an answer. I'm not saying 100%, but this could be an answer. Everyone agrees? Because there are 12 elements here. So somehow it should be 12. That's it, right? Now let's go to option number D and see. We have 1 into 1 into 2 into 3. That sums out, or basically, what do you say, gives it as 6, right? So obviously, this also becomes incorrect. Everyone got it? The total number of size, I mean, the total size does not match. That's the whole point. Now let's see. Let's go into the context here. Everyone understood the concept behind. Let me rub few of these things to make it much more cleaner to look at so that we understand the concept here. Now, in order to make this simplistic is, so what I try to do generally is I say, because I think, the best thing about an array is it is homogeneous. And when I say homogeneous, I just say, I don't say that it is homogeneous just across what you say, the element type. It is also homogeneous in terms of shape. Can you see this? If you see a big building, guys, right, having two floors, it is like that. Can you see the first floor is exactly having 6 elements. The second floor is again having 6 elements here, right? If I talk about, I'm just trying to keep it as an imagination. Meaning, what I mean to say here is I think I might have to just a little bit. Uh, I forgot. I have to use this. I think I will. What is this option? 2 into 2 into 1 into 3. Okay. I will forget maybe. So I will write it on top. I want to explain one more thing here. So Jay's option was 2 into 2 into 1 into 3. So I'm just keeping it on top. So now I just want to tell something here. Guys, notice one thing. Can you tell me what will happen if I do this? Can anybody tell me what will happen if I do this? Did we all see the change which I did now? I removed one big element from there, right? So can I? My question is, will it run or will it not run? What do you think? Any ideas?
It will run.
Okay, sir. Anybody else? Okay, others says it will run. Okay, anybody else?
As you say, it is homogeneous. I think it won't
Yes, sir.
run.
Actually, it will not run. Let me run it. Let's see what is the error message we see. Look at this, sir. It says value error. And let's see, sir, what does it say? Can you see this? It says setting an array element with the sequence, the requested array has inhomogeneous shape after 1 dimensions. The detected shape was 2 comma plus the inhomogeneous part. Why? Because it is like an under constructed building. I have a, what do you say? I am having 2 floors, right? The ground floor and the first floor, but the first floor is not completed yet. So that is fundamentally what is deviating from the principle of an array. An array should be, the best part of an array is it is homogeneous in its elements, meaning the type of elements, meaning what kind of elements you are choosing, plus it is also homogeneous in terms of its shape as well. Do we get it? Is it understandable? That is why you can always, it is very easy to visualize an array because you always know that the array must have these many number of elements. It cannot be an under constructed building like that. Is it understandable by everyone? And I'll now give an example of, we'll come back to the same example and understand the context here. But this is possible with a list, by the way. I can have this as a list. I hope everyone understands. Let me rub this off. Oh, why do I have such a big eraser? I think that would, yeah. So I take this guy here, let me copy it, and I'll say list, and I'll say LSC. Can you see this? I hope everyone understands. The fundamental difference between an array, which I wanted to elaborate on this, right, versus a list, which you can see, you can have any, I mean, that's what list makes, I mean, list becomes very powerful in that feature. But, and obviously I can reference the elements individually by going inside them and looking into it as well, right? So, is it clear for everyone? Did we all understand one thing, this particular thing? Is it
Yeah.
understandable? Perfect, sir. Thank you so much, sir. So when I do this, I have actually given an under constructed array, meaning you can see that it is looking somewhat similar to this, right? I mean, it might be very difficult. I don't know how to make it a little bit easy. Maybe I'll use some brackets. I don't know. I'll probably use like this. This will make it much more easier to see. It might look complex, but that's the whole idea. Do you get it? You can see that this is well constructed. Why? Because there are three brackets inside and three brackets outside here. But these and you can see inside that the two brackets are having, right? You can see there are two such elements, but this one is lacking one more element which needs to be there to be part of it. Did we all get it? And that is why, let me just maybe copy this, and maybe I'll just put this off here. Maybe I'll just put it this way. You can now see that in this context, right? If I run it, you can see it runs now. Why? This becomes well oriented to look at, right? Is it understandable to all of us? The subtle line of difference between an array, I don't know. I mean, it is the easiest possible way I can make it. Maybe something in those lines. It is too easy to visualize, to talk about. Is it understandable by all of us?
It's like I think it's
Huh.
like two batches we have, right?
Yeah,
You're
exactly,
creating
sir.
two batches or like
Yeah.
two
Two
containers we have.
container. Yeah, yeah. The
Yeah.
container is further containing two more containers. Do you see that, sir? That's I mean, it's like I mean, that's what I was trying to imagine. Like there is a big building, right? Each building having like this is like having 0th floor and 1st floor, and each building having some rooms, right? So if I talk about in the context, in fact, there are two rooms to talk about. Let's look into that, right? And the context, I'll make it. And within those two rooms, there is, let's say, again, 2 BHK. Each of them is having 2 BHK or something in those lines. I mean, just to give an example, I mean, it's very difficult to talk about, but still, trying to make you picturize the thing. Is it understandable? A little bit, maybe. It will be more clear once we understand how the thing works out. Is it understandable so far? Yes, everyone?
Yes, Saumya. Yes.
Perfect, sir. Thank you so much, sir. Let me move forward here and discuss about one more important point here. Now, the question was, what is the size of the array, right? Or sorry, what is the shape of the array? The size we know is 12, right? Now, I think I just changed the orientation a bit. Can you see this picture, right? And let me do this. I'll make it a little more elaborate. Now, how do I know the size? Let's see. So imagine, let me make it a little bit more bigger so that it is easy for me to write. So imagine I'm standing here. I'm standing inside this first box, right? Now, if I'm standing here, can anybody tell me
I think Saumya is stuck, or is it from my side?
Yeah, I was also thinking same. On that stuff,
Saumya,
I think.
I think, got internet
Ha,
issue, I think.
even I switch off my camera so that I can see my bandwidth. Soumya, you are not audible. Hi, Saumya.
Oh, hi, sir. I am very sorry. I think there was a network.
Able to hear you now.
Again gone.
Again.
Hello. Hello. Sir, am
Yeah,
I
yeah, yeah.
audible? Thank you so much, sir.
Audible.
Actually, there was a big, uh, okay, as Aziz sir is going, no problem, sir. Yeah. So, yeah, I think the screen is also visible, right, sir? Uh,
Yeah. The question is also like
Perfect.
understandable. Uh,
Perfect,
I
sir.
think you are
Perfect.
asking that if you are sitting on the
Right.
first square bracket,
Right, sir.
then
Exactly.
from where how
Inside the
many
first.
element we can see?
Correct, sir.
Yeah.
Exactly. If I'm standing here,
Okay.
so imagine I am outside the building. What can I see from there? Can I see the rooms inside?
Single building only.
Yeah, I can see the single building. And can I also make an assumption that how many floors are there in the building? Is it possible to say from outside the building, sir? How many floors can there be?
Yeah. If
Based on
it
the
is
windows,
under
right?
vision, then
Yeah.
we can.
Yeah,
Yeah.
right. Sir. Generally, many of the buildings have windows. So based on the windows, we can say that these are stacked one top of the other, right? So from outside, I can say that these many number of buildings are there. I mean, floors are there in the building, right, sir? Perfectly said. So I am standing here. How many elements do I see? Can anybody tell me now? This is the
I
thing.
think from
Perfect.
there only
Perfect.
two elements.
Exactly. And those two are nothing but this entire thing is element one. This guy can see. The next element which I can see is this one, right? Perfectly said. Is it all understandable now? Right? Sir, every one of us understood? Is it
Yeah.
clear for others as well?
Yes.
Yeah.
Yes. Yes.
First
Perfectly.
blank is filled now. It's two.
Yeah, exactly, sir. So we are coming back to the blanks. We have four blanks, right? The first blank is filled with the number 2. Perfect. So I see the first one here, and this is the second one, right? So zeroth and the first one, if I talk about. Now, what I do is let's say, I take another color, and now I'm going inside. I told you, right? One more important point which I mentioned to everyone that uh, arrays are homogeneous. That means, will everyone agree with me? Can I go to floor 0 or floor 1? Both will be identical to each other in terms of the number of elements.
Yes, yes.
Everyone
Yes.
agrees? Yeah, perfect,
Yes.
perfect, sir. So for our convenience, let's go to floor 1. I can go here as well, or I'll probably go
Yeah.
inside this. Okay. So let me change the color here. Maybe I'll use green color. I'm standing here now. Now standing there, how many elements do I see?
Once again, I think it's uh 14, 22, 31, like one block, and then
Right.
another block.
Perfect. Does everyone agree with this? Do everyone agree with this? Because if I'm standing here, this becomes block number 1 and this becomes block number 2. So I'll probably say this as maybe 1 this way and 2 is this way. So to change the convention. Is it do all of us agree? Yes or no?
Yes,
And
yes.
how am I making it? Because I see two brackets here. So in order to match it, I should match it with two brackets, right? The moment I see two brackets at the end, I will consider that as one block. That means one room. Now I have entered the building. I've gone to the first floor, right? In the first floor, there are two rooms, right? You can see room number 1 and room number 2 in the first floor, right? If I talk about now, in that case, if I'll put the number 2 in the second bracket. Is it all understandable by everyone? Yes? Did we all get it? All of us? Clear? Right?
Yes.
And just to iterate again, I told you, right? What do you say? The property of homogeneity still holds true. Why? You can see 3 elements here, again, blocks like this. You can also see 3 elements here, same block. So if you look into this, right, it looks the same way, right? If I talk about whether you go to the 0th floor or whether you go to the 1st floor, right? So I think, I mean, irrespective of wherever you go, you still go into that, right? Everyone got it, right? Yes? Yes? Clear about it? Yes? Shall we move forward? Yes or
Yes.
no? Okay, sir. Now I'm
No, yellow.
taking this. Yeah, okay, yellow. Maybe we'll take yellow soon. Now, now consider this. Inside, I'm going to room number 2 maybe, and I am standing here. Sir, is this yellow color visible to you? I could create it, but still. Yeah, I'm standing inside that. Now, how many elements are visible? Can anybody tell? How many elements
I
are
think
visible?
only one element because this single block we are
Yeah,
considering as a whole now.
exactly. You start from this bracket. Obviously, you have one bracket here. You must have one more bracket here at the end. That's it. So you start at the starting point, wherever that bracket terminates, that entire thing becomes one block. Is it clear for everyone? Yes or no? And same property again holds true. If I had chosen room number 1, then also I would have been having only one, what do you say, element inside. If I went here, I will still be having one element. If I go here, I'll still also be having one element. Don't do we all agree now? Everyone got the concept here, right? So
Yes.
perfect, sir. This becomes 1, right? And finally, let me take the blue color. I am, let's say, inside this. Now I'm inside the room. So what do I see? How many elements do I see? Finally.
3.
Perfect, sir. Exactly. And those elements are 14, 22, and 31. And that's it. Similarly, had I been here, I would also have seen again these 3 elements. Had I been here, I would have seen these 3 elements. Same way here also, right? So 3 elements will be part of it. So that's why the entire thing, the shape of the array becomes 2, comma 2, comma 1, comma 3, which was originally told by Jay. So that is indeed correct. Did we all get it? Yes or no? Is it understandable to all of us?
Yes.
Yeah,
Perfect, sir.
it's like two containers, and
Uh-huh.
that each
Huh.
container has two matrix, and
Yeah,
each matrix has one row and three columns.
yeah, 1 row and 3 columns. Exactly, sir. Exactly. Exactly. That's correct. That's right. That's right. The analogy, I thought the analogy of the building would be easy. That's why I try to visualize it in that manner for all of us. A building, then a floor, then room, and maybe, I mean, within the room you have that or whatever, right? So perfect, perfectly said, sir. Everyone understood? Yes?
Yes.
Perfect, sir. So let me rub this off.
There was some
Yeah.
network issue. Can you please just tell me the last one? Three. How is the three we are getting?
Okay, okay. Yeah, yeah. Sure, sir. Sure, sir.
Yeah, yeah.
Sure, sir. So within this, the reason why we are getting 3, let me, I don't know, I'll just rub this off maybe. Yeah. So, sir, if you remember the last one which we have, right? I am inside this bracket. I go inside and I'm standing here. If I stand here, sir, right? Then suppose now I entered the classroom. The classroom contains student 1, student 2, and student 3. Same way, if I again, because I told that the entire structure is homogeneous, meaning it has to be the same across all the classrooms. So classroom 1 is also having 3 students. Again, classroom 2 is also, if I'm standing here inside this bracket, I have 3 elements again. Same way here also 3 elements, or here also 3 elements. Is it understood, Aman?
Yeah, yeah. Thank you so much. Understood.
No
Yeah.
worries, sir. Perfect, perfect, sir. Perfect. Awesome. So I hope this entire thing was clear. Took a little bit of time, but I hope the crux is clear. Now, would you like to practice in one more question? Should I give you a question? Would you like to try it?
Yeah, yeah. Sure, sure.
Perfect, perfect, sir. So I'm going to maybe add a little
After
bit
that,
more
we'll
of
have a break.
yeah, sure. Lot of arrays, huh, sir? So let me do
Break is
this.
necessary.
Break is necessary, sir. Okay, sir. This is my question. What will be the I have done some changes, a few changes. Now, I would like you all to help me. The first question, obviously, the same question I would like to ask is, I mean, what was it? Yeah, I mean, the what dimensional array is this which I have created?
60.
Sir,
6D.
num 6D. Yeah, perfect. I heard 60, sir. Sorry, sir. 6-dimensional array. Perfect. Yes. The number of brackets suggests the number of dimensions. Perfectly said. So I will have 6 dashes to fill. Everyone agrees, right? Perfect. Now, given the concept which we have just discussed, right? Let's see how we look into this. Yeah. By the way, can I also ask this question? Maybe what will be the size of the array? So this is the 6-dimensional array. What is the size of the array?
12.
Perfect, sir. Exactly. There are 12 elements. So I think everyone agrees that whatever we do, the multiplication of each of it should result in 12, right? Everyone agrees with this piece of information, right? Now that we know the concept, right? Now let's look at it. What are the options we have? Anyone? You can start by helping me with
I
starting
would go
numbers.
for
Yeah, yeah, sir.
2, 2,
The
comma
first number
2,
is 2, comma.
2,
Yeah, sir.
comma 1,
Right, sir.
comma 1,
Okay, sir.
comma 3.
1, 2, 3, 4, 5, sir. There are 5 numbers. There should be 6, right, sir?
I missed one. I missed one. One
Yeah.
second.
Okay, sir. Right. No worries. Oh, I did not print it for you last time, right? I did not say dot size, right? I'm sorry, kids. I'll do it for this one, maybe. So, or maybe the shape, dot shape. I could have used that. I forgot to do that. I'm sorry. This time we'll do it. So, where do you think, sir, we'll place? I think, sir, you got the idea
Yeah.
here. 2 into
2,
2 into
comma
2
2,
into 3.
comma 1, comma 1, comma again 1, comma 3.
Okay, perfect. Let's write that option down here. 1, comma 3, right, sir? And do we have anyone else here? Sir has said 6. Okay. Yeah, 6 dimension. Perfectly said, sir. That's Adarsh's option. Anyone else? Any other options? Anyone? The number of brackets seems confusing a bit. Huh? Yeah. Someone unmuted. Yeah. Would you like to say? Anyone? whatever you feel like. Okay, so let's discuss, right?
I
Okay.
think the first element should be 1.
Okay. Nice. 1 comma 2 comma 1 comma 2 comma 1 comma 3. Okay. Okay, we have an interesting option here. Says 1 comma 2 comma 1 comma 2 comma 1 comma 3. Was that correct? Desert, is that correct? I've written whatever.
I'm
I
just
think that.
assuming actually that
Yeah,
there are
yeah.
lots
No
of
worries.
bracket.
Yeah, no, sir. Yeah, exactly. There are a lot of brackets. Yeah, sir. A little bit. I thought of giving a little bit complex, so that it becomes a little easier once we discuss that. Sir. Yeah. Indeed, I think Aman Pare, he mentioned that the first element should be 1, right? In fact, let's see. Let's discuss about it. So I think the same way I stand here, right? So if I talk about, right, I see starting 5 brackets, right? 1, 2, 3, 4, 5, right? Everyone agrees? So there are 2 brackets ending here. So obviously this is not the ending point. There are 4 brackets ending here. Obviously this cannot be the ending point. There are 2 brackets here. This cannot be the ending point. So there are 5 brackets. So naturally the ending point becomes these 5 brackets. Are we getting it? Now I'm talking in terms of a bracket so that it becomes more straightforward to talk about. Is it clear? So that means this, even if I go inside this entire thing, this entire box becomes 1. Is it understandable by everyone? Is it clear to all of us? Right? So I start here. So this is my starting bracket. So there are 5 brackets, right? Because I'm entering this first bracket, right? So I think you can understand why. I hope everyone understands why I'm saying entering the first bracket, because this will give me. Let me say this will give me. I mean, sorry. This point inside, right, will give me dimension number 1. This point inside will give me 2, 3, 4, 5, and finally this will be the 6th bracket, right? I hope everyone understands. That's why I'm entering the first bracket. Is it understandable by everyone? Yes or no? Here to it? Yes?
Yes,
Everyone
sir.
got it? Perfect, sir. Perfect. So, others, am I boring you? I think, yeah. So I have this bracket. So you have starting 5. These 5 brackets are ending here. That means the first element becomes 1 because this entire thing is 1 element, right? Now, let me rub this off so that it is easy to understand. Now I'm standing in this point, right? Now, when I stand at that point, right, I can see 1, 2, 3, 4 brackets, right? Everyone agrees? I can see 4 brackets. These 4 brackets have to be identical. In order to close it, I need to have 4 brackets on the right, but this is having 2 brackets. That means it is continuation, right? So then I have 1, 2, 3, 4 brackets. You can see that I can match these 4 brackets to these 4 brackets. That means this entire thing becomes one block. Is it understandable? Yes or no? Guys, all of us, is it
Yeah.
understandable? Yeah, this becomes block number
Yes,
1.
yes.
Yeah. Same way, there is 4 brackets here, ending again here as 4 brackets. That means 1, 2, 3, 4. That, where is that 4th bracket? 1, 2, 3, 4. So this becomes the second block. I hope everyone understands, right? I hope that's clear. So that's why I'm putting, since there are 2 elements here, so I say 2, 1, comma 2. Now, given that point, now I was standing at this point earlier. Now I go inside this, right? I'm standing here, right? I see 3 brackets, right? Everyone agrees that we can see 3 brackets. Yes or no? Everyone got it? Yes? So I think everyone
Yes, sir.
understands. Yeah, yeah, perfect, sir.
Yes, sir.
So yeah, I'm going inside the first one. So I have started. I see 3 brackets here. So starting 3 brackets, where should I end? Should I end at this point? Yes, no? Should I end it at this point? No, right? Because there are
Oh,
three
no.
brackets. Yeah, I'm trying to end it at 2. So I continue. The 3 brackets actually end here. That means this entire thing is just one element. Again, obviously, since I discussed the rule of what do you say, homogeneity, even had I been standing here, I still should see one element. That means this becomes again 1. I hope everyone is clear with the same, right? So I think I'll just rub it off a bit so that it is understandable. I am inside this, right? If I talk about, you saw me entering this 1, 2, 3 numbers. I've already written 3 numbers. Now I'm standing inside this. I'm standing here, right? So if I stand here, I have starting 2 brackets. Where should it end? Where should it end within this?
The
Because
first,
this
this
was,
one, sir. Yeah.
yeah, exactly, sir. Right, exactly. So this guy becomes one element again because early the previous bracket was containing these 2 elements, right? If I talk about, so that same thing applies to this as well. So there are 2 brackets here. So this becomes my second element, and that is why again same thing. Had I been standing here, I can see 2 and 2 here. Everyone agrees, right? And that is what happens here as well. I put the number 2. Everyone got it, right?
Yes, yes.
Perfect. Let me just rub this off here a bit, whatever. Yeah, I think that's it. Yeah, so I'll probably, yeah. Now that I'm inside this, right, I can, like I was inside these 2 brackets, right? Now I can stand here, right? Inside this bracket. I can see only one single bracket here, right? So there is starting point 1 bracket. This has to end with 1 bracket here. That means this entire thing is one element, right? Same way, had I been standing here, same way I had this one element only. Same way here also I had this one element and one element. So you can see that I can put here as 1. And finally, if I enter this bracket, if I talk about, how many elements do we see in that particular contiguous block? If
3.
I enter, yeah, exactly. Perfectly said. So the final element becomes 3. And that is why the shape becomes 1 comma 2 comma 1 comma 2 comma 1 comma 3. And that's why B becomes the correct option. Although these both match in 12, like meaning the number of elements are 12, but however, you can see that this does not match in the context. If I talk about in the words there, right? So if I talk about in the context. So I hope that's particularly understandable by everyone. And just to show it to you, you can see 1, 2, 1, 2, 1, 3. If I talk about, so let me clear everything. Just to show it here, let me take this entire thing, dot shape. You can see here that it shows me 1 comma 2 comma 1 comma 2 comma 1 comma 3, and that becomes the shape of the pattern. All clear with that, sir? Everyone? Is it understandable by all of us?
Yes, sir.
Yes, sir.
Perfect, sir. Thank you so much. So I'm sorry, guys. So it took a lot of time. So we can take a quick 10 to 15 minutes break and then we'll return back. I will zap through the other concepts quickly because this was one thing. If the fundamentals of NumPy are clear, it will be very easy to always visualize even bigger arrays. So it becomes very easy to look into those. So, so to speak. So thanks for being a wonderful audience up until now. So let's meet after 15 minutes. Okay, sir. Hello, sirs. Am I audible to all of you?
Hi, sir. Good
Yes.
afternoon.
Hello, sir.
Yes,
Good
yes, you are
afternoon, sir.
audible.
Yes, sir.
Right, sir. Perfect, sir. Sure. So, had break, everyone. So, shall we continue forward?
Yes.
Yes. Okay, so sir, before going, we were just discussing about how the size of the array can be calculated, and based on that, what is the shape of the array and stuff, right? I hope that becomes clear for all of us, many of us, like in the context where how things work out, right? So you can see the attribute shape for which we just looked into the context here, right? So if I talk about, right? So let's move forward and discuss about few more things in the context here. So, all right. So I hope it's clear up until now. Now, moving forward, right? Array has different kinds of operations. If I talk about all of those things can be particularly done if you talk about, right? So you have an array A and B, and you can go ahead and print those the sum of two arrays. And I think you can understand that if I talk about it adds the element, I mean, does the element by element addition, right? So 4 to 5, 5 to, I mean, 2 to 5, and 3 to 6. And by the way, today I will share all the, I think it didn't caught up my mind yesterday. I'm really sorry for that. Well, today I'll share all the files with the executions and everything. So that it is there for reference for everyone. So I think more or less it's understandable. You can see element-wise addition happens and stuff, right? If I talk about, right? Now, a very important concept within arrays called as broadcasting, right? So earlier I told, right, that you can, right, add up arrays if you know, if this the rules for broadcasting is not applicable to everything, right? But meaning thanks to the vectorization process which happens in NumPy, right, it creates a copy of itself and then it does the calculation. For that, let's understand it how it happens a little bit in the context, right? So broadcasting lets NumPy work with arrays of different shapes during any arithmetic calculation and stuff, right? If I talk about the broadcasting rules, right? If I talk about, right, prepend 1 to the shape of the smaller array until you have the same number of dimensions. Let's talk about it in the context there, right? So I'll rather not discuss about the rules in words. It would be better to see it within with an example. So before I move forward with it, right, I would like you to tell me what do you think will be the output of this? You have a very simple array A and a simple array B. Now I do A plus B. What do we expect the output to be in this case? Anyone would like to go ahead and try? And whatever you think like, I mean, not so um, hardened to that same thing, but whatever. What do we think?
I
Uh,
think, as per my point of view,
right,
like
sir.
11, 22, 33, and
Right, sir.
14, 25, 36.
11,
Not
22.
sure it is right or
Right,
wrong.
sir. Right. Okay, sir.
11,
11,
22,
22.
33,
Right, sir. And
and 14, 25, 36.
14, 25, 36. Right, sir.
Mm.
So you think that would
No,
be
it is right
yeah,
or
yeah,
wrong. I don't
right.
know.
Right, sir. Right, sir. Perfect. That's okay, sir. So, but I'm happy if tried here as well. So if I talk about, right. So now, if I talk about, I think, sir, you thought of the logic in the context here that you took this, you added this to this element, right? Then you did the same with this, right? 22, 33. and you did the element-wise addition to these things, right, sir? And indeed, that is actually perfectly correct because in the context here, by the way, one more question would be, um, will it be a 1D array or a 2D array? That's one more question I have for everyone.
The output.
I think
Yeah,
we
sir.
can add
Sorry, sir.
Output one-dimensional array. One-dimensional array.
So meaning whatever I've written, that would be correct, right, sir? Meaning there is one bracket here, that's it, right? Meaning 1D array,
I
right, sir?
think so.
Okay, perfect. Okay, sir. Aman Baji, you had something in mind?
no, I was also saying the same 1D array was
Okay.
expected. No.
Okay, sir.
Yeah.
Okay, sir. Okay, sir. So meaning basically you have the one bracket and bracket here, right? So let's have a look at the output and then discuss about it. Let's do that. So I think this shows us that it is actually a 2D array, right? If I talk about in the context, right? The output, it becomes a two-dimensional array on the context which we are discussing. Now let's see how it is working. Okay, so to understand that, right? I have this array here, right? Uh, can anybody help me with the shape of the array? What is the shape of the array here? What is the shape of the
2,
array here?
3.
Perfect. Perfect.
2,
Exactly.
3.
Perfect. Right. 2, 3. Basically 2 rows and 3 columns, right? If I talk about. And what is the shape of the array here? Anybody?
3, I guess.
Right. Meaning generally, sir, it is a one-dimensional array. So we call it as 3 comma nothing. We just keep it, or you can also say comma 3, whatever, depends on whatever you talk about. It is basically one-dimensional, and hence it shows us just one number. Everyone agrees, unless and until you have two of it, right? Now, here's the thing. What internally happens, right? So we have a matrix of 2 comma 3 and we have a matrix of 3, right? If I talk about, right? So basically what happens, the rules of broadcasting, right? What does it say? Basically, how is this operation happening? It's happening because of the broadcasting rule. And let's understand the rule. So you have array A, which is of size 2 comma 3. You have array B, which is of size 3, right? Or in fact, it shows or shape. I'm so sorry. Shape as 3, right? If I talk about now, so what the rule says? Rule number 1, right? So look at the, what do you say, dimension of each of it. So you see that this array is 2D, whereas this array is one dimension, right? So the idea is duplicate the smaller one. That means array B, duplicate the array B such that it becomes a 2D array. And how do you duplicate? You don't add one after. Instead, you prepend one, meaning you add one to this here. So I think it is safe to understand that now if it becomes 1 cross 3 or 1 comma 3, this has been upgraded to a 2D array. Does everyone agree with this? The moment I have two numbers, that signifies that I'm talking about a 2D array, right? Everyone agrees to this point? All of us? Everyone got the context here, right? So the moment I write or prepend 1 to it, right, I am adding two numbers. I'm sorry, I have gotten two numbers. That means this 1D has been upgraded to 2D. But when I write 1 comma 3, can you help me recreate this array? How it should look like when I write it in 1 comma 3 manner? How should I write it actually? How should it look like? How many brackets should it be there and how should I write it? My idea is that I'm writing 1 comma 3. I have to make this array in that manner, right? So what should I do? I have this. Initially, I had this, right? I hope everyone agrees. initially it looked like this, right? So how should I write it so that it becomes 1 comma 3? Anybody can help me with that? Currently the size is 3, right? And just to iterate, let me just show it to you here, right? Let me say print B. We can all see that it shows me this, and B dot shape, I say whatever, right? So SHAPE, I'm sorry, APE. I think we can understand it safely says 3 comma nothing. So it is basically a 1D array. So how do I make it 2D? How should it look like? When I write it as 1 comma 3, how should it look like, by the way? Can anybody tell me? This is the array here. Anyone? Originally, I think everyone understands it was this, right? 10 comma 20 comma 30, right? Now this is 3 comma nothing shape, right? Now I am upgrading it to making it 1 comma 3. How should I write? I think everyone safely says that basically when I write 1 comma 3, that means there should be 1 row and 3 columns. Everyone agrees, right? Yeah. Yeah, perfect, sir.
Yes.
So, yeah. So there is 1 row and 3 columns simply means there are 3 elements, right? That's it. So I write it as 10 comma 20 comma 30. Does this, everyone agrees with this, right? I upgraded this guy here, which was earlier 3 comma nothing, to making it 1 comma 3. Is it understandable by all of us? Got it, right? Yes?
Yes.
Perfect, sir. Perfect. Awesome. Awesome. Now that I have upgraded, right? So obviously now my upgraded array becomes bracket bracket 10, 20, 30 and bracket close, right? Now, obviously my original array was 2 comma 3. A is of shape 2 comma 3, right? Now upgrade has become, and now it has become, B has become, it has been upgraded to 1 comma 3, right? Now look at, if you look into it, right? The next rule of broadcasting. So rule number 1, I hope everyone understands. So compared to what do you say, two arrays, the smaller of the two array should be having that same number of size like that of the larger array. And how do you do that? You just append 1 continuously in the beginning and then you add the last number. That's it. So rule number 1, I hope it's crystal clear for everyone. All of us got it? Right? Perfect. Easy enough to understand. Shall we move to rule number 2?
Yes.
Perfect, sir.
Yes.
Thank
Yes.
you. Perfect. So now rule number 2 says, now I have A comma B, right? It has become 2 comma 3 and 1 comma 3, right? Now rule number 2 says, compare the last two numbers. What do you see? These two numbers are equal, right? If the two numbers are equal at the end, right, then you don't do anything. You move your cursor to the second one adjacent to it, right? So you start off from the last. These two are this. If this is n, this is also n, right? So basically this matches. If it matches, don't do anything. Go to the next one, which is previous to it, right? Now, again, do the same thing. Try to match it. Are these two numbers matching? 2 and 1, are they matching together? Obviously 2 is not equal to 1, right? I hope we all understand that, right? So since 2 is not equal to 1, right, what I'm doing is I want to duplicate the one which is smaller so that it becomes 2. I want to duplicate the smaller one so that it becomes 2, meaning my output should be, I should reorient in such a way that this 1 comma 3 becomes 2 comma 3. I keep it in the form of 2. And how do I do that, right? Basically, obviously I have said 2 comma 3. So you are doing repetition. The whole idea here is we are going to repeat those numbers. So these are the numbers here, 10, 20, 30. I want to, it is very easy to say that I want to duplicate the numbers in the row axis. Everyone agrees? Because I want to upgrade it to the number 2, right? So I have to, what do you say? Um, uh, Upgrade the row axis, or maybe duplicate along the row axis. So what will be the output? How would it look like? It should look like this: 10, 20, 30. This is 1, and 10, 20, 30. This becomes the second one. And obviously, there is 2, right? And I think everyone understands there is no more terms before it, right? So we wind up here. Now we finally have two arrays, array A, which is 1, 2, 3, 4, 5, 6, and finally the broadcasted shape of the array B, that is 10, 20, 30, 10, 20, 30, and then we can perform the addition pretty easily. And final output again becomes two-dimensional because it is the broadcasted shape of the array. Is it understandable by everyone? Did we all get it?
Yes, Saumya.
Perfect, sir. Perfect. So this is the overall rules of the broadcasting. So when broadcasting simply means you create copies of the same to do vector. I mean, that's how the vectorized operations take place in NumPy. I hope that's particularly understandable in the context here. So that is why what happens, and that is why, can anybody tell me what should be the output in this case? I just added a, what do you say, bracket. I added one more bracket left, one more bracket towards the right. What should be the output in this case? What do you think? So I think let's go by the size here. So see, all the arrays cannot be broadcasted. It is not possible to broadcast everything. You can't do broadcasting to everything. Those which follow the rules can only be broadcasted. And that's how you get the output. So in this case, what is the shape of the array A? Again, the shape of the array is, we just saw, that was 2 comma, what do you say, 2 into 3, right? That is the 2 comma 3 or whatever, right? If I talk about 2 comma 3 is the shape of the array. What is the shape of the array B here? What do we see here as the shape? Anybody? Can anybody help me?
1,3, I guess.
Right, sir. Exactly, sir. Perfect. The I wrote the updated question. So the array size, or the, what do you say, array shape becomes one, I mean, it is 1 comma 3, and that means one row and 3 columns, right? If I talk about now, what am I doing? I'm trying to add it up. Now again, let's see the rules of broadcasting. So first of all, are the dimensions equal? Yes. So there is no need for extra dimension. That means the output should be two-dimensional array in the context here, right? If rules of broadcasting succeeds, then it will be, output will be a two-dimensional array. We get the concept that, right? Now, second rule of broadcasting, it says start from the end. So we see 3 comma, 3 from array A, 3 from array B. We compare, both the numbers are equal. Yes, correct. That means I move towards the second, right? Now, I compare 2 and 1, if I talk about, right? In this context, obviously, is, can I create multiple copies? If so, to which axis should I add? So I think you can understand, it is safe to say that I have to make this 1 comma 3, I want to change it to 2 comma 3 in order to do the addition, because 2 comma 3 can be added with 2 comma 3 in the context here. So what do I do? Again, the same thing. The output will basically the same thing. I have 20, 30, and I have 10, 20, 30. And then obviously now it becomes 2 comma 3. You created a copy of it in that same, in the row axis. And that is why when you do the addition, again, it becomes that same thing, right? If I talk about, if you look into the context, you see that it still shows me the same thing. Is it understandable by all of us? Did we all get it? Everyone got
Yes,
it, right?
Saumya.
Perfect, sir. Now let's see where broadcasting may not be applicable. Let me do that. Now, I added one more number here, right? If you look into, right? So what is the shape of this array? We already know that it is 2, 3 for the first one. What is the shape of the array for the below one?
1, 4.
Yes, sir. Right. It is 1, 4. Now, let's see the final rule of broadcasting. Now, what I did not say anything if it does not, what you say, if the numbers are neither one nor they, if they match, what happens in that case? You saw that one of them was 1. That's why we were able to multiply or maybe duplicate in the same axis, right? And make it 2, right? 1 can be multiplied in that same axis. But let's see what happens in this case. You have numbers 3 and 4 here. Is 3 equal to 4? No, 3 is not equal to 4. And second rule is any of these, so there are two rules, right? One is, are the two numbers equal? Yes or no? To answer that question, this is no, right? And the second question which we ask here is any of these numbers equal to 1? Is it yes or no? What is the answer to that? Is any of these numbers equal to 1? What will it be? What is it?
From both, you were asking from both the arrays or
No,
first
from
one?
here, from here. So the first, if condition
No,
one
no.
fails, yeah. So there are two conditions you always have to check. Are the two numbers equal? Yes. Then you don't have to do anything. You just have to move towards the left side. But if the two numbers
I
don't
think
match,
Saumya,
the second, yes, sir. Yes, sir.
I think in short, we are just checking the one dimension, like number of elements are equal or not from the both input. That's what
Right,
that
sir.
second
Yeah,
argument. Yeah.
exactly. Exactly, sir. Exactly. Because here 3 is not equal to 4 and neither of these numbers is equal to 1. That is why you wind up getting that you get no for both of it. Then you don't go anywhere. That means those two arrays cannot be broadcasted together at all. And that exactly what happens if I run this program now. Can you see this? It says operands could not be broadcasted together with shape 2, 3 and just like we discussed 1, 4. Is it understandable by everyone? Did we all get it? Easy to understand, right, sir?
Yes.
Perfect, sir. Perfect. All right. So let me just, I think that's pretty straightforward to talk about now. And so I think more or less it's understandable to everyone here. So let me do this here one more. Maybe I'll take a equals to, right, and b equals to, let's say I have these two numbers, right? Okay. So I have a equals to this, right? And b equals to 1 plus 2, 1, 2, 3. What do you think will be the output of a plus b? Can anybody tell me? I am sorry. Oh, I forgot np.array. This broadcasting rules is applicable for NumPy arrays. My mistake. np.array. Do that. Yeah. What do you think will be the case here or in the context here? What will be the output? Anybody would like to give it a try?
13, 33, 34, and 4.
So, let's see. You said 13? Yes, sir. 33.
13 and 34 and 4. I guess I am assuming from the previous task.
That's okay.
Yeah.
Understood, sir. Understood. Let's have a look first, right? then you, as we just discussed about, right? Indeed, right? So we understood the concept here, right? So the smaller of the two arrays becomes upgraded to the what do you say, the output of the first array, right? If I mean the one which we discussed
Right.
about here, right? Perfect, perfectly said, right? So I think the rules are getting familiar a bit, right? How things work out in the context here, right? Perfect, perfect, perfect. Let me introduce to one last question. Maybe I will take this. Now, what should be the output? Perfect, sir. Very nicely said. I hope things are getting clarified for everyone, right? So, more or less, what we are trying to discuss here. Everyone understood the previous question, right? So, the idea was this is array of shape 3, right? It gets broadcasted to 1 comma 3, and this is already 1 comma 3, and that's why both of them get added, and that becomes the output here. Everyone got the concept. Anyone getting doubts there? All of us got the concept there, right? Everyone understood, right, sir?
Saumya, before this,
Yes,
I
sir.
think it would be 2D array, right?
Yeah, perfect, sir. Let's discuss about it. Yeah. So you have this, right? Array
No,
A
no,
is nothing
down,
but
down,
one.
down one,
Ha, sir.
down one.
Ha.
Actually,
Yeah,
last you
this
given
is
the example, no?
right, sir.
Ah,
This is
right,
1
right, right.
comma
Yeah,
3,
that one, that one.
right?
Right, right.
B is 3, right, sir? Yeah,
Mm,
perfect.
mm.
That gets upgraded to 1 comma 3, and then it becomes a, just like how you said, sir, it will be
2D.
a
Yeah,
2D
yeah.
array.
Right, right. Yeah, fine.
Perfect, perfect, perfect. Right. Awesome.
Now, I think for this,
Yeah.
as per my
First,
point of
yes,
view,
sir. Yeah, sir.
the first 2D, two-dimensional array,
Right,
and
sir.
first row, which is consist of like 13, 33, 2.
Okay. First row consists of 13, 33, 2. Okay, sir.
2. And the
Okay.
second 14,
Okay.
34, 3.
Awesome. Okay.
And the final one 15,
Right, sir.
35, 4.
Brilliant, sir. Brilliant.
I don't know
Perfect.
exactly right or wrong.
Uh-huh.
Consist of
Nicely said,
2D
sir.
array,
Yeah,
individual
it is.
like row and column
Right.
makeup.
Right, sir. Exactly. If you talk about, I'm very happy and glad about that we attempted it. Indeed, yes. But how does it work out internally? That's the question. Just like sir said, let's quickly look into it. I think all of us got the idea of how broadcasting happens. So A has a shape of 1 cross 3, right? Everyone agrees, right? One row and three columns, right? Now B has, what is the shape of the array B? Can anybody tell me? What is the shape of the array B?
Uh, B.
B, sir. Yeah, B1. What will be
B
the shape
also,
of
I
the array?
think it is uh, 1 comma 3.
3
No,
comma
sir.
1, I guess.
3 comma 1. It will be
No, no, 3 comma.
opposite.
Yeah, R comma
Yeah,
C.
yeah,
R comma
exactly.
means
Yeah,
3
right.
comma 1. Uh,
1, 2, yeah,
3 rows,
exactly. Just
1
like how
column.
three
Yeah,
rows and one column. Perfectly said.
1 column.
Yes.
Yeah, yeah.
3 comma 1. Exactly, sir. Exactly. Just like how we have mentioned here. So we just discussed about the rules of broadcasting. How do we start? Obviously, we have written this. So first we check dimension. Are both the dimensions same? If not, go with the smaller dimension and append one to the beginning. But both of these dimensions are the same. So we don't have to worry about that, right? Because this is also 2D and this guy is also 2D. So if I talk about both of them are 2D. So that rule is done. That means my output, if broadcasting gets successful, will be a 2D array. Everyone agrees to that, right? Now, what we do, sorry, sir, someone unmuted, is it? Any questions, sir?
No, no, sorry,
Anyone?
sorry. Nothing,
Okay,
nothing.
okay, 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 no worries. Perfect. So, how do we go next? We see the last two terms. We compare this. What do we see here? The number 3 and number 1. What do we do here? I see a number 3 and I see a number 1. What do I do here? So the first thing which we check, are these two numbers same? Yes or no? What is the answer to that? Obviously, these two numbers, yeah, perfect. Exactly, sir. Are they same? So I'll write the rules of broadcasting. Same, that means it is no, right? Both of the numbers are different. One is 1 and one is 3. Now, okay, fine. If it is no, then we ask the second question. Is any of these number equal to 1? Is any of them 1? Yes or no? Is any of these numbers 1? Did we all get it? The concept here. The second question which we are asking here is any number equal
One
to
is
1?
there, no?
Yeah, exactly. That's the whole point, sir. Yeah.
Yeah.
So, yeah. So one we are asking is any. So here any of them equal to 1? Yes. In this case, you have yes. So if it is yes, that means now what you have to do is broadcast or sorry, duplicate along that axis. That means this 3 cross 1 has to be upgraded to 3 cross 3. This 3 cross 1 has to be upgraded to 3 cross 3. I hope it's clear for everyone. That means I should have 3 rows and I should have 3 columns in the context here. How do I have that? You can have this element which I have written here. I had 1, 2, 3. I have to duplicate along the column axis, meaning I have to duplicate these elements. That means I'll have 1, 1, 1, and then I'll have 2, 2, 2, and I have 3, 3, 3. This is what I am expected to get so that it becomes a 3 cross 3 matrix. It has to be upgraded to a 3 cross 3 matrix. Is it clear for everyone? I have to make this 1 to be upgraded to 3. And how do I do that? Because 3 is there in the column axis, I will duplicate along the column. So 1 gets duplicated along the column, 2 gets duplicated 3 times, and 3 gets duplicated 3 times. Is so far so good for everyone? Is it understandable to everyone?
Yes.
Perfect. 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 So this gets upgraded to 3, 3. Okay, now we are done with this, right? Now I will rub this off. It's no longer 3, 1. I'm directly writing here as 3, 3. So I have done this. Now, obviously, now this matches. I shift 1 here. I have 3 here. What other question should I ask first? What is the question should I ask first here? I have to compare these two numbers. What is the first question I should ask?
Anyone is equal to 1?
No, sir. The first is I'm
Okay,
checking
that
whether
is
those two are, yeah, exactly. If they are same, that means I mean if both of them are 1, then that's fine as well. But the first question which we ask is, are both of these numbers equal? Is it true or false? The answer is, I think, false, right? Because 1 is not equal to 3. So that means the first answer is no for the first this one, right? Then we move, since this is no, I will go to the second question. Had these been yes, then I do not have to bother about asking the second question because both of them are same. I anyhow have to shift, right? If both of them are same, then I anyhow have to shift to the left side. I don't do anything, any operation, right? Now, the next question I'm asking here is any of these guy equal to 1? Yes or no? What is the answer to that? Is any of them equal to 1? In this case,
Yeah, right. One is there.
yes.
yes. Yeah, exactly. The first array has a number 1, and that's why I have yes in this. Now my broadcasting rules become successful. So what do? I go to array A. I have 1 cross 3. This was it, right? I had 12, 32, 1 in the array values, right? What should I do? I have to upgrade this guy to 3, 3. I make this as 3, 3. And what do I do in that case? How should I make it 3, 3? Obviously, I'm going to duplicate the column, sorry, rows in this case, right? So this row gets duplicated. That means it becomes 12, 32, 1, and again 12, 32, 1. And that's why, and obviously this entire thing is within one bracket. Now you see that the final, you can see it becomes 3 cross 3, right? So now we are evaluating 3 cross 3 and 3 cross 3. We are doing an addition of these two. Obviously, it is possible. So that's why you get, I mean, you saw, right? 12, 12, 12, 32, and so forth. All you have to do is, let's see, did we do everything correctly? So I write 12, 32, 1, 12, 32, 1, and 12, 32, 1. I already have this guy here. I'm not making brackets. I'm just showing it to you. So I hope everyone it will be actually in this manner. So it should be having 2 brackets here, 2 brackets here. So I hope everyone understands. So, but I'm just giving it. So now I add this up. So 12 gets added to 1. That's why you get 13. 32 gets added to 1. You get 33. 1 gets added to 1. You get 2. And so forth. You can see 12 gets added to 2, you get 14. Then 32 gets added to 2, gets 34, and so forth. Is it understandable to all of us? Because if we understand the rules of broadcasting, there might be some complex arrays. You'll be very easily able to say whether these two guys are broadcastable, yes or no. Everyone understood? Yes or no? All of us got the concept here, right?
Yes.
Yes? Perfect. Perfect. That is great. So obviously, broadcasting rules is not applicable always, as we just discussed about, right? So I think more or less we understand the concept, how it works out in the context there. So would you like to see for a 3D here? Maybe it'll be a little bit complex, but I would say आप उसको घर पे करके देखना एक बार. So look into the rules. If I say 3D, basically one cross inside this, I have one element, and I go inside this, I have I think, oh, it is 1 cross I, 1, 2, 3 elements and one element inside this. I hope everyone understands this, right? So since it is a 3-dimensional array, the first thing which we do is prepend 1 here, right? Because this is smaller of the two. So I do it as 1 cross 1 cross 3. Then let's see. So all you need to do is it broadcastable, yes or no? If you want to find the answer, let's see that. So I make it as 1 cross 1 cross 3. This is possible. Then I see these two guys here, right? If I talk about one is 3, the other one is 1, right? So obviously this can be broadcasted to 3. I think everyone understands. I move forward here. I compare these two numbers. One is 1, one is 3. Obviously this can be broadcasted to 3 again, right? Obviously now I move to the next. Obviously both of them, like, we ask the same question again, right? Are both of them same? Yes. And is any of them 1? Yes. That means no need to do anything further. That means if this is possible, that means it is possible to broadcast these two together, right? And just to show that off to you here, let's have a look. You can see that you get the broadcasted array as well. It's understandable, right? That how things work in the broadcasting manner. And you can even create it from scratch, from like with pen and paper. So a lot of interesting stuff can be seen. Is it understandable to all of us? Shall we move forward? All of us?
Yes, Saomya.
Perfect, sir. Thank you so much. Let's move forward. So I think these were a little bit complex topics. Now I'll probably zap through the others. Very straightforward. I think more or less we all understand the concept here. It works out pretty straightforward enough. We just saw, I think, one of the examples. This is broadcastable. Why? Because we have what? 3 cross 1, and this is basically 3. That means I think everyone understands that how it works out. 3 cross 1, and this is only 3. That means you first append 1 to it, and then you check these two, make it 3. Then you go back, you check these two. These is one of them is 1, make this 3. So this becomes 3 cross 3 plus 3 cross 3, and that's why you get the 9 elements in the context here. Okay. More or less. There is a specific explanation The written explanation is also there. I believe it would be boring to see that. That's why I didn't much talk about that, but you can always look into that. So pretty straightforward. If I talk about, you can see now things become very easy and straightforward. You have an array. We have the array, which is so and so forth. I'm doing a square root. There are like these are U functions, or what do you say, universal functions, if I talk about, because these are called as universal functions because they implement vectorization process. So you don't have to worry about. You can see I'm just using np dot square root, and the function get applicable to the entire array by the vectorization process. So if I talk about, it gets done on the entire array. No need to worry about each of it. So the entire array gets the stuff, right? So the sign of it, right? And then you have the exponent, right? So e to the power of 1 is 2.7 roughly, if I talk about. And then you have you e to the, what do you say, 4, if I talk about in the context here, or exponent, sorry, exponential of the same. So aggregates, if I talk about, you have the sum. Aggregation is like having few numbers and getting one out of it. So in the context here, you have sum, you have min, max, mean. Many of them are there. So just to talk about, you again, just like we just discussed about, right? We can add up, like I can do in the form of axis as well. If I write sum of the complete matrix, you get a single number. What does it do? It takes 1 plus 2 plus 3 plus 4. But if I say axis equal to 1, it goes like, let me show it to you here. Maybe it'll be easy for you. So it is always good to have a nice structure so that it is easy to understand. So I say axis equal to 0 simply means I go inside this, obviously, that is the 0th axis, and 0th axis has these two elements, right? So these two get summed up. You see 4 and you see 6. That's why, right? So now if I say axis equal to 2, you are inside this. So these two get summed up and these two get summed up, if I talk about, right? So in the context. So had there been axis equal to 1, then you would have seen 3 comma 7 if the context holds true. But we have taken mean. That means 1 plus 2 divided by 2. That is, what do you say, 1.5. And that's what you see here, right? And 3 plus 4, 7 divided by 2, you get this, so and so forth. If I talk about, just to elaborate on the context there. So minimum and so forth can also be used with axis as well, right? So it is going to give you a array with containing those minimum values, right? So next, basic indexing, if I talk about, we talk about in terms of, let's say, the same way you have for list, right? Array of 0 gives me the 0th element. Obviously, array of -1, both of them are applicable in the context here for arrays as well. Obviously, I can also have array of what do you say, length of the array, if as well, if I talk about in the context. So I hope that's particularly understandable, that it gives me 50, right, in the context here. Now, slicing operation works pretty much the same as in the form of a list. If I talk about, you start at the first index, you end at the fourth index, but however, you don't consider the last one in the context here. So let me print the array here for the reference purpose and print those in the context here, right? If I talk about, you start at the 1th location, go all the way till the 4th one, right? So if I talk about, right? Obviously, the step size is applicable. Same way, if you keep it blank, it defaultly takes the first place. And that is why you see this, right? If I talk about, the first number becomes 10. And because it is same way of writing it as 0, 0 colon 3, or maybe if you talk about, again, in the context there, in the aspect, right? So, and just like how we know about having -1 reverses it, right? So moving forward in the context here, right? If I talk about multi-dimensional indexing, right? So I think we have seen more complex arrays. This becomes very easy to implement, right? We have seen 6-dimensional arrays and we have done operations, how it works out, right? In the context there, right? So that way it becomes much more interesting if I talk about in the context. So obviously, one thing to keep it in mind is there, if you want a single element, we should, because I hope everyone understands, this is a two-dimensional array, and that is why there should be two arguments if you want a single numeric number. So suppose you want the number 3, in that case you should have that like 0 1 comma 1 sorry 1 comma 0, that should give us 3, right, if I talk about, right? So I hope that's particularly understandable by everyone in the context here. And yeah, there is one question which I have. Can anybody tell me what will be the output? Here you get, what do you say? If I say maybe matrix of this dot shape, I think you can understand that it is a 0-dimensional. Everyone agrees, right? If I write matrix of 1 comma 1, right, it is going to give me a 0-dimensional array, right? Everyone understood that point? Why am I saying that? Is it clear for
Yes,
everyone? Perfect, sir. Perfect.
I think it
So
is
one
going to retrieve only one
right.
element.
Exactly,
That is 4.
right, sir. Exactly. That is going to retrieve only 4. Exactly, sir. Perfectly said. But when I write it like this, what will be the dimension then? When I write it like this, what will, first of all, what do you think will be the output? Can anybody help me with the output? Could you help me with the output? What do you think? What should be the output for this guy, line number 6? What should be the output here?
I think 0th element of each row.
Right, sir. Okay.
I don't think so, right or wrong,
Okay.
but
No, you are correct, sir, actually, right? So I am saying when I write this, everyone knows colon means everything, or I would say all. Colon
yeah.
simply means all, right? Exactly, sir. I am saying take all of this. What is this first one? This is the row. I am saying take all the rows. And what am I doing for the next one? I am saying take the 0th column. And that is why I'm saying that the output shall become this guy here, 1 comma 3 comma 5. But my question is, one more question I have, will it be a one-dimensional array or a two-dimensional array? Can anybody tell me that? The output, what do we expect? Will it be a one-dimensional array or a 2D array? The output. What do you think?
In my point of view, maybe tuple of element, but I'm not
Right, sir.
because long back I studied.
Okay, sir. Okay, sir.
So
Okay, sir.
maybe
Yeah.
tuple of element, I think so.
Right, sir. Let's have a look. Actually, sir, it will be a one-dimensional array. Let me run this to understand it. So maybe I will say first, or let's say first, maybe I put this, whatever, and so that we have this, or maybe I'll do this. It'll be easy because that way I'll have to write a lot of things. Maybe I would rather put print. I will say multiply by 10, or maybe let's say 20. I will just introduce these so that we have a nice web between this stuff. Where did I make a mistake? Let me. Yeah. Yeah, I am making a mistake here. Okay, so the first one we can see matrix 1 of 1. It gives me a single element that is obviously the shape is 0. Obviously, it's a 0-dimensional array if I talk about in the context. Then I have matrix all rows and single column. You can see that it shows me the output is one-dimensional array. Why? Because I have fixed this position. Can you see one pattern here? Why did I say this is zero dimension? It's because this number is a fixed number. This is also a fixed number, right? I hope everyone agrees. Both of them are fixed numbers, and that is why you get a zero-dimensional array. This can be told as a zero-dimensional array, array having no dimension. Now, here I have the moment I put all, right, that gives me the flexibility that I'm talking about a series of things. That means it can come up in any number of in that particular dimension, it can come up with many number of elements, right? And that's why you see, but zero is again a fixed element. That means earlier it was two dimensions, but one of them is fixed. That means you are left out with the answer is the output becomes a one-dimensional array, right? Same way happens here as well. I think everyone would safely say that this will also be a one-dimensional array. The output will be a one-dimensional array. Last but not the least, in this case, why is it a two-dimension? Because you have colons, which is not fixed, which is saying the output is not fixed. We are not referring to a particular. The idea is very simple. The number of colons signify the what do you say, the number of dimension of the output of the particular vector. Is it understandable by everyone? That's why it is a 2D array here at the end. Even though I have written zero, even if I write like this, if I talk about in the context, obviously this is going to give me 1 comma 3, and if I say 1 comma 2 0 comma 1, you will see, can you see this? It is a single number, but still it is a two-dimensional array. Why? Because I'm saying start at 1, end at 2, right? If I talk about, right, that means it is introducing, I think start at 1 means I'm saying for row, I'm saying, so this is the 0th row, this is the first row. I'm talking about this, right? And because I'm saying take only the first row because the second number is 2, that means I cannot take this, right? So this is the patch which I'm talking about. Out of this patch, I'm saying go from 0, but stop at 1. That means I'm saying 0th number, but not including the first number. And that's why you wind up getting the number 3, but it is a two-dimensional array. Is it understandable by everyone? How can I make it single dimension? You saw it earlier as well, right? I can write it in this format, right? So if I say like 1 comma 0, I should be getting 3. Is it understandable by everyone? Yes or no? All of us got the context here? Sir, everyone?
So,
Perfect. Perfect. Thank you so much. So I think more or less we understand the concept here. There's the Boolean indexing. Indexing simply suggests that I can even use operators to see which numbers are greater or smaller. So suppose all the numbers which are greater than 3 shall be fetched in this context here. By the way, if I print this, this is only going to give me Boolean true or Boolean false, right? I hope everyone understands. The output of line number 2 will be Boolean true or Boolean false. So I think it will be, I hope everyone understands, it will be false, 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 true, true. But I'm saying fetch the numbers which are greater than that. So array of those numbers, whatever you are talking about in the context, and that is fetched as 4 comma 5 here. I hope that's easy enough to understand. So there are basically 3 kinds. If you talk about Boolean indexing, you can retrieve elements using by doing Boolean indexing, or obviously you can do slicing, or in the context which we talked about, you can also retrieve elements by indexing. So a simple use case scenario which we discussed about, right? So now reshape, if I talk about, helps you to shape it again, right? But there, let me say this. Can I do this? Can anybody tell me? Is this possible? Yes or no? Can anybody tell me that? I hope everyone first understands. The first line says np.arrange. That means starting from 0 to 12. That means it has all the numbers from 0 to 11, right? And I am saying array.reshape 3 comma 2. Is this possible? If so, what will be the output? What do you think?
I think not possible because the number of element it is I think 12. So
Right.
the multiplication of the row and column is equal to number of element.
Awesomely said, sir. Yes, exactly. And this is exactly what you can say that cannot reshape array of size 12 into the shape so and so. Obviously, perfect, sir. And obviously, can I do it now? Is this possible? Would this be possible, everyone?
Yes, it is possible.
Yes, I hope so.
Perfect. Obviously, perfect. As said nicely, that is indeed possible. So obviously, I have this three elements, 1, 2, 3. Then you have 2. That means inside the bracket, you have 1 and 2. And then there is 2, 1 and 2. I hope that's particularly understandable and sustainable as well. I can make it more complex. Obviously, I can have something like this as well. That is a little bit complex to see, but I think everyone understands that this is also safely possible, very easily said, because the multiplication again comes out to be 12. So this resize is possible. Obviously, it is a little bit different to see, but however, it works out in the context there. I hope that's clear for all of us. Flatten and ravel. Basically, flatten is what basically creates a new copy, if what do you say, of an array, right? But ravel, when we talk about, right, it returns a view. That means in the context, if I talk about, right, I have this. If you look into, I have an array which is, let's say, 2 comma 2, right? I think that's understandable. So array which is taking is 2 comma 2. I flatten the array by using flatten, right? And what am I doing is basically I'm changing the element, right? So what do you say, flat of 0. I think you can understand flatten will, by the way, both flatten, let me tell you one more important point. Both flatten and ravel, right, create a one-dimensional array. It's like, imagine you have a hammer and you whatever, like you make the cube as plain sheet, right? That's the whole point, right? So flattening and raveling both make the what do you say, array one dimensional, but one is a copy of it, the other one is a view of it. What is the difference? So what is this difference between the two? Can anybody tell me? When I say copy versus when I use the word called view, what do you think would be the difference between the two? Any guesses? So I basically, a copy simply means, if I say I have a piece of paper, I put it inside the, what do you say, Xerox machine. This is paper A, and I create a copy B, right? So if I talk about, since that is what I mean, I create a copy of A, but that which is a Xerox copy of A, right? I create B, which is a Xerox copy of A. Can anybody tell me? Suppose if here it was written, maybe let's say I have written here as Saomya, right? And since I have used Xerox, right? And here also, obviously, I create, I created that, right? So in the context, so obviously, I created a copy of it. So if I cross this off and I maybe write X here, right? Will the first one be affected? Will the first one be affected? Because I've created a copy by through the Xerox machine. Obviously, the copied one will never be, I think, right, sir? Yeah, Raja, sir.
I think first one will not affect.
Yeah, exactly, sir. Perfectly said. Yes, indeed. The first one will never be affected. Why? Because I put it inside a Xerox machine. I created a copy of A and I'm calling that B. Now I'm changing letter S. I put it as X. Obviously, this one will be having, Saomya or whatever we call it, but this one will still be having Saomya, right? If I talk about in the context, right? So that is what flatten does. It creates a copy of it. But in Ravel, this is not the case. It also creates a one-dimensional stuff, but it is a view of it. When I say view, that means it is actually the sheet A, and if you make any changes like this one becomes T, right? So Saumya becomes Tomya in the context there. The original one also gets affected in the context of a Ravel. That's the only difference between the two. Is it understandable? I think the easiest explanation which I can give in the context. What do you say? Flatten creates a Xerox copy of it, where the Xerox copy, which are the created copy, is not affected. But this guy, when you talk about Ravel, right? It is, you can say Ravel comes from the word reveal, or what are the contents. But if you change the contents of the item, obviously the overall context also changes. That's exactly what Ravel does. Meaning, if you change the Ravel, can you see this here? That's what I'm writing here. I took flat, that I flattened it. मैंने हथौड़ा मार के उसको flat कर दिया. Again, so if you talk about, I'm taking element 0. Obviously, if everything becomes one dimensional, this becomes 1, 2, 3, 4. I believe that's understandable by everyone, right? Now I'm taking element 0, that is 1, and I'm changing it to 100. So the flatten one, obviously, it is not a, what do you say? The original one is not affected in the context here, right? If I talk about in the aspect here, right? But in the context here, if I say the flattened, if I talk about, I have the ravel here, right? Now I'm raveling it, right? I'm taking the same array, right? And I'm changing the 0th element, okay? So in that case, if you look into the context, you will see the context being changed in the reference here. So original array, I mean, array taken was 1, 2, 3, 4. Then original array got changed because of the fact that you can see Ravel is running here, right? If you talk about in the context, and you can see that 300 gets appended. You can see that original array again. You can see that it is 300 in the context there, right? Because I'm running Ravel prior to that, if I talk about in the context, right? Same way, if I look into the context, that is my flattened array, right? Flat, you remember, I changed this to 100. This is the, I mean, this is a copy, right? The copy will be affected because it is a new array. I changed the element of it, but the original one still is, what do you say, 300. Because why is it 300? Because I have already, I'm putting this print statement after the Ravel. I think you can understand the context. Is it understandable by all of us? You all get it? The idea is flatten creates a copy, and then if you change the copy, the original is never affected. But this is a view of it. So if you talk about a view, if after taking the view, you change some element, that the original one gets affected because you are basically changing the element at the original memory location. That's it. All good? Everyone understood the context? Yeah? Easy to interpret? Yes?
Yes.
Perfect. Thank you. Now, obviously, these are pretty basic. Won't talk about it much. So transposition, it's basically, I can use dot T for transpose, right? So 1, 1, 1, 1 is mirror image. So it will obviously, after transposing, also becomes 1, 1. So, but if I talk about, let's say 3, 2, then 2, 3, that element becomes 2, 3 if I talk about, right? So let's say, print the matrix. I hope everyone understands where is matrix. Sorry. So I have this, and I think print, I will print this, whatever. I think that's particularly understandable. So I have the original matrix, which is containing these. So 0, 0 obviously stays there. You have 0, 1, I believe, that becomes 1, 0. So where is 1, 0? You can see this 1, 0 is this position, and so on and so forth. That's the transposition of the matrix in the context. And post that, we talk about concatenation. Concatenation simply means adding the, what do you say, arrays, if I talk about, right? So you can concatenate, you can see the output right away here. So you can concatenate them in the context there, right? But obviously, I can also use something like access, right, in the parameter here. Let me run this first, okay? So I say I want to concatenate access is equal to 1. I think, where is it? Out of bounds, let me check. A comma B, I have this. Yeah, I have to be very specific. Why did we all get what was wrong with this? when I ran this versus this. Did everyone get it? Why did I get the error while I was trying axis equal to 1? Can anybody tell me why did I get the error here? I think we all understand that the original arrays were one-dimensional, right? A and B were one-dimensional, and I'm trying to concatenate into axis equal to 1. That means I'm trying to create a level. A level can only be created if there is a bracket which is discontinued for the next next array of elements, right? So that's what I'm talking about in this case, right? So in this aspect, I add one more bracket which adds the thing, and now you can see that 1, 2, 3, comma 4, 5, 6 that gets appended one below the other. I think that's more or less understandable by everyone. All good, understandable, easy to interpret is all of us. Yes, no, maybe all of us. Clear, sirs? I think. And there's
Yes, Saomya.
perfect. Thank you so much, sir. I have H stack or horizontal stacking.
Saomya,
You
one
can
thing
yes,
actually,
perfect.
after the
Yes,
NP dot concatenate,
right, sir.
which will become like one dimensional or two dimensional. I think in output it is two dimensional, right?
Right, sir. See, yeah, sir. If initially np dot
Okay.
concatenate, yeah, sir. Initially, np dot concatenate needs two arrays, right, sir? So because you
Okay.
can't, there is no meaning for concatenation if you don't have multiple things, right, sir? You can't add the same element, right? I can either write a comma a, meaning adding a to itself. That because concatenation means you have two objects, you want to add them together, right, sir? So that's the whole point, right? So, but you have to have two arrays, right? In order to.
In this concatenate, actually, first argument we have to give as a matrix, right?
Right, sir. Right, sir.
Actually, we
Exactly.
don't want to give as a like the parameter as a variable like a comma p.
Right, sir. Yeah, exactly. So because
Okay.
concatenation itself, yeah, you're right, sir. Because concatenation itself accepts two matrices, right? So you want to concatenate only two matrices. Only then you will be able to join them together, right, sir? So that's
Okay.
why, and yeah. But if I write it in this manner, there will be an argument problem. It will say you are adding, right? You can see. I mean, it's not able to understand the context. If I talk about, right, you can see it shows me in this format. Can you see this? So I can use a1 comma a2, and I can have any more number of concatenations as well. So I can write it, or I can put it in the form of a list, or just like how it says, I can also have it in this form. So I don't know why does this
I
not
think now
work.
error is coming.
Oh, sorry. Yeah, sorry, sir. Because axis equal to 1. I can put axis
Ah,
equal to 0 to work. Yes.
yeah.
But
Okay.
yeah, right. Sir? So that is why. But if I want axis equal to 1, I have to be specific because I need two dimensions. I'm saying that output should be two
Like
dimensions.
this is called like column measure and row measure.
Right, sir. Exactly. Column major when you have, if you talk about in the column side, and the row major if you are talking to. Perfectly said. Yes, sir. Awesome. So hopefully all of these things are pretty clear, and you can see we have H stack and V stack. We are stacking up matrices on top of each other, right? That's what exactly what it does here. Pretty straightforward to talk about. And I had introduced this final sheet of broadcasting rules for everyone to understand. So guys, I mean, I'll be sharing this file, so you'll be very easily able to understand the rules and regulations behind how the broadcasting actually works out.